Assalamualaikum warahmatullahi wabarakatuh and good afternoon. So this is our second session. So can you guys hear me?
Waalaikumsalam warahmatullah. Can do that.
All right, good. So okay, I think we will do this second session discussing the test one. Okay, and if you don't realize yet, so actually you can check your test one from e-learning. So it's already there. So it's available. Okay, so everybody can check. So already give the marks and then you can check your paper. Okay, just go to the either one of these. So every one of you should have a one only. Okay, and then just click somewhere because this is not a student view. So you'll get your paper. You can check. Okay. And few of things that I think that I need to highlight is most of it is from a question one. Question one A. Okay, so this A1 and A2 both actually many of you is actually making the same mistake, right? So let's see how can we solve this actually. So A1 and A2. Especially something like this one. When you have a minus 2n, and then this one minus n plus 2. Okay. Second one. So because there's a there's a minus n and then plus 2, so this is actually a flipping, and then this is a delay. So we have two operation. So many is actually doing one first. I think doing a flipping first, and then delay later. And then some of you is doing a delay first, and then flip. Okay, or folding. So delay, fold. So which one is actually true? And how do you going to prove which one is actually true? Okay, because if you just try to remember which one first, so maybe you remember it wrong. So then that's not good. Okay, because this is a maths, because we need to strengthen the maths. Okay, not just to memorize which one should you do first, because that will be that is actually not good. That's not how we learn. So we should learn from understanding. We shouldn't learn from memorizing. Right? If you memorize it wrong, then you get it wrong. You should know how to explain it. The same thing here. There is a lot of confusion when we have a minus 2n. So what should we do within this bracket? Because this is a time bracket. The time bracket is actually referring to the index, right? The whole thing is the signal value. Because we have two things. We have always two things. If you look into this kind of equation, so we have the value, the signal value, and then the index, right? So how to interpret this? So, or how do you spell this? So if you want to put it in words, so how do you read it? Maybe you just read it yn equals to x1n plus x2 minus 2n. That doesn't give any understanding. Okay, actually that doesn't give really a real understanding. So if you want to put it in full, so this is actually a function of y in terms of n. Okay, means that the y is actually changing. The y is changing based on n. The y value is changing because of n. And how does it change? So the changing is because of we have a sample of x1 at n, at the current n, plus a sample of x2 at sample at index. So this is a sample of x to n, one sample from x2. But which sample that you need to take at index minus 2n? Right, just one. Every time you want to get one value from yn, so you need to get one sample from x1 at current sample, and then x2 at sample minus 2n. Okay, so actually that's how you read it in full sentence. So you should be able, as an engineer, okay, basically maths is just tools for us. So try, every time you see an equation, try to read it in full. Try to read it in full, so that you get some understanding from it, right? Not just yn equals to x1n plus x2 minus 2n. Okay, again, it doesn't give any understanding. Okay, so let's because I'm going to show actually one of you give is giving the solution which is I'm trying to show today. Okay, so one of you is using that methods. Let's copy that. Yn equals to, at least now we have x1n. Why this is very important? Because DSP is actually, every chapter is related. So we have gone for 6 weeks. So we have 6 chapters already, and everything should be, you need to master everything, because the next we will use everything from the previous. Okay, and then goes to the next and next and next. You need to understand everything first. So we have x1n equals to, if you see this question is a little bit different compared to what you have answer. Actually, we have 2 sets of questions. Okay, so this is a set A. So if your question is different, then actually you are answering set B. So x1n is equals to 1, 1. x2n is equals to 1, 1, 2. 1, 1, 2. Okay. And yn, the first one, which is question number 1, is x1n plus x2 minus 2n. Actually, to get yn, so we just need to solve this equation. And we are actually having this x1n and x2n. So if you want to draw it, so let's try to draw x1n. This is 2, 3, minus 1, minus 2. So you have this for x1n. And if you plot x2n, let's say this is 0, minus 1, minus 2, minus 3. So this is 1, 2, 3. So you'll have 2 here, and then 1, 1. Okay, so why is that? Because we have this line, this underline below 2. So this is actually indicating that the index 0 is at this value. Okay, so far most of you got this right. No problem. You can draw, right? You can draw what is the x1 and 1, 1, x2n. It starts the index 0 at 2 here. So not much a problem. I think maybe more than 90% or maybe 95% of you is actually doing this correctly. Not a problem. So then we need to find yn. So what is actually yn? And if you want to draw, so actually you need to find what are the values of these plots. What is actually the yn value when n equals to 0? What is the value at n equals to minus 1? What is the value at n equals to 1? Etc. Okay. So of course, theoretically, you need to check everything from minus infinity up to infinity. Okay, because that's the full range. The full range is actually from minus infinity up to infinity. But of course, it doesn't need to check everything, because we know that even this one is actually starting from -2. This is starting from 0. So it's not possible that we get a range from minus infinity up to infinity. Okay, so actually so this is where, if you do that, so let's say when n equals to 0, so you are actually checking what is y0. Okay, because if you want to find y0 here, so you're going to check y0, n equals to 0. So what will be the answer? Because the equation is x1, 0 plus x2 minus 2 times 0. Okay, from this equation. So actually, this is what we do. So this is actually what we do. So you have the input, two inputs. One is x1n, another two is x2n. So and then yn is actually a combination of these two with certain operation. Okay, what are the operation? This is plus, and then this is something. This is you need to select something from x2, right? So what is this? So this is just as simple as x10 plus x2 minus 2 multiply with 0. So you get 0. Okay. And what other value? x10 is 1. So this is x10. What is the x20? x20 is 2. So because this is 2. Okay, this is n0. So this is going to be a 1 plus 2 equals to 3. So that's y0. So it is 3. And you can go on for n equals to 1, which is y1. This is actually equals to x1, 1 plus x2. This is the part that you get confused. So actually, it is just minus 2 multiplied by 1. Okay, we just, because this is a simple maths. This is a simple maths. So you just do that, minus 2 multiplied by 1, because you are checking on y1. So what is this? So this is x11 plus x2 minus 2. Minus 2 multiplied by 1, so you get x2 minus 2. So what is that? x11 is 1. And then what is x2 minus 2? Now you get this one. It is minus 2. So what is the index of this term? When the n is equals to 1, x2 minus 2. And then just check what is the x2 minus 2. So this is x2 minus 2, which is equals to 1. Right? So actually that one is a 1 plus 1 equals 2. So 3 plus 1 at n is 0. So this one, 2. All right. Then we need to continue, because we're not only checking for 0, 1, 2, 3, 4, 5. So we need to check also for negative parts. But let's try this one first. When n equals to 2, so you will get y2, which is equals to x12 plus x2 minus 2 multiplied by 2, which is equals to, this is still x12 plus x2 minus 4. x12, 0. x2 minus 4, so which is somewhere here. This is already 0, so this is a 0, 0. So this is actually equals to 0 plus 0, which is 0. And we can see some pattern because it's taking from this one. If we do n equals to 3, so we will try to get which is on a higher index. And this one, it goes into a lower and lower and lower index. So this one is already starting to get 0. Then we will be sure that this will be 0. So now let's check on -1. So for y minus 1, so this is actually x1 minus 1 plus x2 minus 2 minus 1. Or we will get x1 minus 1 plus x2. Now, because this is minus 2 multiplied by minus 1, so it becomes 2. Right? We are checking on y for minus index. But because of this, the x2 will refer to the positive index. Okay, because that's the equation. So we just are solving this simple equation only. So x1 minus 1 is 0, and x2, 2. So where is the x2, 2? So this is x2, 1. This is x2, 2, which is also 0. And we can say that because this is starting to get 0, and the value that we are referring is from this one, from here, it's already 0, and then this one, increasing n, it is actually 0. Then we can be sure that these are all 0. So that is our yn. Okay, so what is the yn? Yn in vector form, it is just 3, 2. Okay, so what is actually this one? This is actually, we are trying to refer to some index. So it's not like, because most of you is what you do is you multiply the n. Right? So this is y1. When you check y1, so you are making this into 2n, and then flip it. So from minus, and then you try to make it into a positive. Right? So that's wrong. That's wrong. Okay. So it's supposed to be this one. We call it. There is also some name for this one. This is a selection. Selection means this x2 minus 2n going to take some samples of this only. It's not going to take full samples, because what will it take is only this one, this 2, and then this one. So it will skip this one. It will skip this one. Okay, it will skip that one. So, but of course we need to check that equation. So then it can be solved, something just solving this simple maths, and then you will get it. Okay, you will get that one. And a big error is, I think maybe there are 2 or 3 of you. So you have, because this is by minus 2n, somehow you have a 0, I think maybe something like a 0.5 and then 1. Okay, so this is a big mistake for discrete time system. It doesn't have 0.5. Everything should be integer, nombor bulat. Okay, not possible to have this one. So hopefully don't do that mistake again. Okay, a total error for discrete time. Okay, any question? Any part that you don't understand or still confused?
I don't have a question.
Yes.
Because I know that I have misinterpreted this as a time shifting operation, like, the 2n. But there is a question that asks to do that, right? What is? Because I don't know when the question asks us to do time operation or just selection.
Yes, actually this is also folding, because we have minus. Okay, this is actually a folding and selection in one operation. So, but because everything is, but which one should you do first, selection or folding? So that one can be a very, sometimes very difficult to memorize, very difficult to memorize. Okay, so because that's why actually we just need to solve this equation. So then we doesn't need to memorize it. So is it, that's why if you do this one, actually you doesn't need to know that whether this is actually selection, is this a folding, is this a delay. Okay, but to be specific, yes, this is actually folding and selection in one go, Okay, so it is safe just to solve it such this. Okay, let's do the second one. Okay, do you have any question more?
Because I thought that we have to like change the signal, do modification on the signal.
Yes, you can do that also, but need to make it carefully. Okay, I'll do that. Okay, change the signal first. So, okay, let's say we have this x2. Actually, the problem is here, x2 minus 2n. We have, what is it? So we have yn equals to x1n. So this is another way of doing it. Plus x2 minus 2n. Okay, and we can put it such that let's say this is a yn equals to x1n plus, let's say this is a xan. Okay, so why I do that? Because now I have, this is n, this is n. Okay, we're going to solve this one first. So what is a xan? It is a x2 minus 2n. So this is why we're going to solve this one first. Okay, so actually this is what most of you try to do it. You solve x2 minus 2n first. Actually, the right way of writing it, we are representing this term by another signal. So such this, so I'm putting it as xan. So what is the xan? The second term. So the second term. And then again, so we have x2, so which is 0, 0, minus 1, minus 2. So this is actually 2, this is 1, this is 1. This is becoming 0. So this is the original x2n. What we are trying to solve? x2 minus 2n. Okay? So that you get xan. So then it will be easy to sum these two. x1n, sum xan. Right? And then let's see. So here we will see. So how the folding and the selection is done. Because now we are referring to this term alone. Okay, instead of this one. This one we already combine everything, solve everything in one go. Okay. Okay, so to do that, same thing. So it is actually the same thing. So we're going to check at n equals to 0. So what is actually xa? 0. So this is x2 minus 2, 0, which is x2, 0. And that one is actually equals to 2. Right? x2, 0, that one. That one is x 2. And then we move x for n equals to 1, so we get xa 1, which is x2 minus 2, and this is actually equals to this one, which is 1. Right? And if you go for n equals to 2, you get xa2, which is x2 minus 4, which is equals to 0. Okay, and the rest will be 0. If you increase the n, so it will be 0. And of course, we need to check the negative part also. This is xa minus 1 becomes x2. This is minus 2 multiplied by minus 1. So that one will be x2, 2, which is 0. Okay, which is a 0. So we can check that. Same thing that we do previously. So that we know that it will, if n minus 2 minus 3 minus 4, it will be 0. It will be 0. So what we have is actually xan. Xan. This one is actually equals to 2, 1. Okay, that's 0. And then this is 1. So this is 2, 1. If we sketch, so this is 2, this is 1. What is this? So this is xan. So if we compare these two, now we can see that, so this signal, it will take these two, and then this one, skip this one, okay? So this is actually the results of this value multiplied by 2. It becomes a selection. So it select only 0 and then minus 2, the even negative index. And then there's the negative in front, so it means that this is actually folding. So it fold. So it fold it this way. Okay, from this one, it fold and select. So that's actually what's happening. And then if you do this, and then plus with x1n, and what is the x1n? X1n is a 1, 1. So this one plus 1 becomes 3. This one plus 1 becomes 2. So this is actually the process of folding and selection. Okay,
understood that.
Right?
Got it.
So
thank you, Dr.
What most of you do is actually you becomes something like this. This is 2, this is 1, this is 1. So you are multiplying the index by 2.
Exactly, yeah.
And then you multiply the index by another 2. Okay? So that's why if you solve this equation, you won't get this thing. So, right? So that's actually, we need to really understand the operation on this index. Actually, this is, you are referring to some index. So what is the x2 minus 2n? So you need to solve this. What is the x2 minus 2n? If n is 1, it is actually x2 minus 2. Something like that, right? So hopefully, so don't get confused anymore. And the way to solve it is actually to solve the index. Because what is actually this, in digital system, everything is actually in memory. So I repeat this many times already. In your memory, and your memory is actually when you try to call a value, so you are actually finding an index, and of course in your memory you are finding the memory address. Okay, so we need to imagine that. So this is our original. So how do we pick this value? So how do we pick this value? So actually that's the process when it is when we are solving inside the bracket. So which one should you pick? Right? Do not expand it this way. And what is the value? The whole thing. So which is x2 which index? Okay. And that thing is actually can solve number 2 also if the understanding is now clear. So which one first? Should we do a folding first and then delay, or should we delay first and then folding? Right? Maybe some of you will say that I heard that we need to do delay first and then folding. And then someone says that my senior says that we should do folding first and then delay. So, but do you know which one is true? Which one is correct? So actually do not memorize, we need to understand it. So actually it's very difficult to memorize. So which one is supposed to be first? I myself did not memorize it because I will get confused every time. So which one is supposed to be first? The main thing is actually we need to solve this equation, right? Because this is an equation. It's just a simple maths. So we should solve it, right? So, and then again, this is actually referring to some index. So this u, which index should we pick? All right, so then it will be very easy on so whatever the process inside the bracket, so we don't care. Okay, let's do that. Yn equals to minus n plus 2 and then minus x1n. So we will do this approach. Okay, we will do that approach. I need to add some page. Right, so the question is, so hopefully it becomes clearer after we do this second example. So what is a yn? Yn is actually u minus n plus 2 minus x1n. Okay, just checking whether it is correct. U minus n plus 2, and this question, number 2, it doesn't involve x2. It involves two signals, which is the x1n and a basic signal. We call it, this is actually step signal. Okay, so what is this? So this is actually step signal. Step signal. And I think all of you got it right. This is actually step signal. So no one is doing this on a different signal. Okay, no x2n. Now it's just a step signal and x1. X1. So, and if we want to draw, okay, I think most of you got this correct. No problem. And for signal which expand until infinity, so normally how we do it is we put infinity here, put the 3 dots. If the value is everything similar, put the 3 dots. Okay, showing that this is a continuity. So, all right, so that's how we write it. So this is a un, and then again, so this is actually x1n. And then to solve this, again, what should we do is just we need to find what is our yn. And we should do that from minus infinity until infinity. Okay, but of course we can stop somewhere where we already know that it's the value doesn't change. Okay, so but actually basically we need to change from we need to check from minus infinity up to infinity. So let's start with let's say 0. Okay, so actually it doesn't matter which one you start. So n0, the y0 becomes u minus minus n minus 0 plus 2 plus x1 0. Okay, so what is this? So this is actually just a u2 plus x1 0. Then what is a y0? U2. So this is 0, 1, 2. Okay. So we have a value 1. And then what is a 1? X1 0. X1 0 is 1. So this is just 1 plus 1 equals to 2. Sorry, this is not plus. That one is minus. Minus. Then this one becomes 0. Okay, that's solved for n equals to 0. Then we can continue n equals to 1. So y1 is actually equals to u minus 1 plus 2 minus x11. And this one gives you a u of 1. And we know that's u of 1. Again, okay, u minus 1 plus 2. U1 is u1 u1 is 1, and then x11 is 1. So, all right. Is this correct? 1 minus 1. Feels like something is wrong. This is 2, x1, u2 is 1. So 1 minus 1 is 0. So this is 0. Okay. So if you get somewhere wrong, because I think I feel something wrong. This is 0. y2, this is actually minus 2 plus 2 of x12. This one becomes u0 minus x1, 2. 0, 1, 2. And this is a 1 minus a 0, which is 1. Okay, this is 1. This is 0. Okay. So okay, so now we have 0, 0, 1. So if we proceed, so this is y3. So this is becomes y minus 2 plus 3 plus 2. So which is x1 3. This one is u minus 1. And u minus 1 is now 0. Minus 0. Okay, so it will start giving us a 0 value here. So I think if we continue, for y4, y5, so we'll get a 0 also.
Doctor, I think there's a correction for n equals to 0.
N equals to 0? Okay.
x10 is actually 2, not 1.
Pardon, again? x10
is 2, right?
It's 2. Oh, I'm referring to a wrong value.
I have 1. Hold on.
1, that one is 1. So this is 1.
It's 1, okay.
So okay, so that's correct. Okay, so far I think this is correct, right? Because this is actually 1, 1. Okay, let's check on y minus 1. Sorry, not y, this is n. N minus 1, so you will go for a y minus 1. So this is a u a minus 1 plus 2. Plus, sorry, not plus, but minus x1 minus 1. Okay, and then this one becomes u3 minus x1. This is still minus 1. So this is u3 is 1. And then we will minus with x1 minus 1. That one is a 0. So equals to 1. All right, and then if we go our n equals to minus 2, so this one becomes a minus, sorry, minus. See, I'm making a mistake here. This is correct. Oh, okay, it's correct. 3. So u3. So if this is n equals to minus 2, this is a y minus 2. So then this one becomes u2 plus 2, u4. So this is u4. The same thing. It will be a 1. So then it will be still a 1 minus 0. So the rest will be 1 minus 0. So at 0, now we have a 0. At 1, it is still 0. At n equals to 2, that one is equals to a 1. and then the rest will be 0. Minus 1. Minus 1 start getting 1. So this is a minus 2. So you will get that 1. Okay, so if you continue with that one. Okay, and actually what is this? So this is actually, if you do the this one by one. So this is actually, you need to a delay first, a flip first. Flip first and then delay. Okay, so if you want to memorize that. But you can prove it such this. But I still feel something is wrong. So, okay, if there's an error, you should correct it. But that's how we do it. We can just do solving the equation by checking the n. So from n0, n1, n2, n3, and then check the negative n. So this is minus n. And because this is infinite, so you need to check that one, okay, until minus infinity. And because this is just a un, every value is just 1, so it is easy to check. Right? So this is where we have this one. This is 1. Okay, try to check that one again. So maybe some of this value is wrong, but that's the idea. Okay, so any questions? I think the second one, that one is not a problem. Many got it correct. So even the testing, some of you got confused a little bit on something, but I think the idea is most of you got the idea. And question 2, finding poles and zeros is not a problem. So many get it correct. And then just the B, maybe some of you is actually a little bit confused on getting the range of alpha. Okay, so the range of alpha is many got it right. This one is which one? Determine is it to be causal and stable. This one is the alpha is here, 1 is here. So you should describe the ROC, which is the Z, which is greater than alpha, and alpha is actually supposed to be less than 1. Okay, and of course it's supposed to be greater than 0. Okay, so that's a complete answer. Less than and equals. It needs to be less than. Okay, if it is equals, then will not include the unit circle. Right? Okay, so not much problem on that one. Just a normal confusing, but this question 1A. So hopefully you get the idea on how to solve it, and how does we actually put our data in a discrete version. Okay, it is everything is a vector. It has an index. So how do you refer to the index? So hopefully everything is clear now. Okay, any questions? Any last questions? So hopefully everybody already got your paper back, and then check if there is any mistake from me marking it. So let me know so that we can do the so that I can correct the marks. Okay, all right. So that's all for today. We will start a new chapter this Thursday. Okay, because it doesn't have time to do that today. Okay, assalamualaikum warahmatullahi wabarakatuh, and good afternoon, everybody. See you guys next on Thursday.
Assalamualaikum warahmatullahi. Thank you, Datuk.
Waalaikumsalam. Thank you, Doktor.